Hello students, till today we have considered definition of the sets, type of sets, representation of the set, set operations, union, intersection and difference. So we'll consider few more concepts with the same set theory. Today we'll take a complement of a set. Complement of a set. What the definition says? If U is the universal set and A is the subset of U, then the complement of A denoted like this, A dash is the set of all elements present in U, not in A. Set of all elements present in U, not in A. So, I'll repeat. A complement. It is complement of the set A, where A is the subset of universal set. So A dash, it is a set containing X such that X belongs to U and X does not belong to A. For example, I'll take universal set as 1, 2, 3, 4, 5, dash dash till 10. Take A, 2, 4, 8. Now, if you want to write A complement, see there is a usage like this, A dash. You can write A to the power C also. This also indicates A complement only. So A dash equal to, see here, except the elements of A, that is 2, 4, 8, you write all the elements which is remaining in U. So leave 2, 4, 8 and write all other entries. 1, 2 cannot be, 3, 4 cannot be, 5, 6, 7, 8 cannot be, 9 and 10. So this is A dash or A complement. Now tell me, if you consider one more time the complement of A complement. A complement, complement of A complement this is, right? So now see here, this is A complement with elements 1, 3, 5, 6, 7, 9, 10. Now leave all those entries and write the remaining entries from U. So that is 2, 4, 8. Now is this 2, 4, 8 equal to A? Yes. So the conclusion is double complement. Complement of A complement gives you A only. Complement of A complement gives A only. This is a property actually. See, this is a statement. A dash equal to. It is a set containing X such that X belongs to U and X does not belong to A. So you can write this A dash as U minus A. It is there in U, not in A. It is U minus A. Example. See, the universal set is 1, 2, 3, 4, 5, 6. Set A is 3, 4, 5. Now, if you want to write A dash, leave 3, 4, 5 from the universal set and write all other entries. That is 1, 2 and 6. So A dash is 1, 2, 6. Consider the properties now. If you take A union A complement, union of A and A complement gives you universal set. If you take intersection, A intersection A complement, that gives you null set, means no common entries will be there. If you take double complement, gives you A only. U minus A dash, say this is also equal to U minus A dash. If you consider the same example, leave A dash, that is 1, 2, 4, 1, 2, 6, except 1, 2, 6, write all entries from the universal set. That is 3, 4, 5 and that is given set A itself. So we can conclude complement of A complement, that is U minus A complement, that gives you A only. That gives you A only. Consider one more example. Take U as 1, 2, 3, 4, 5, 6. Take A as 3, 4, 5. Take B as singleton set with entry 1. Then A dashes except 3, 4, 5. That is 1, 2 and 6. B dashes except 1. That is 2, 3, 4, 5, 6. Right? Now, A union B complement. First you have to form A union B. Consider the union of A and B together. That is 1, 3, 4, 5. Take the complement. So 1, 3, 4, 5. If you leave 1, 3, 4, 5 from the universal set, we'll get 2, 6. Consider A intersection B complement. Then if you compare with these two results, A complement union B complement and A complement intersection B complement. See here, A union B complement, that is 2, 6, which is same with A complement intersection B complement. Similarly, A intersection B complement, that is equal to A complement union B complement. This law is called De Morgan's law. See, written like this: A union B complement equal to A complement intersection B complement. A intersection B complement is equal to A complement union B complement. So I'll give one more example to that property, De Morgan's law. Take A equal to 1, 2. Take B is equal to 3. Then take the universal set 1, 2, 3 and 4. Now form A union B, union of A and B, that is 1, 2 and 3. Form A union B complement. Leave 1, 2, 3 from the universal set. So the what is remaining entry, that is 4. Number this is equation 1. Now consider A complement. Except 1 and 2, that is 3 and 4. Write B complement. Except 3, that is 1, 2 and 4. If you take the intersection of these two, A complement intersection B complement, intersection of these two, common entry is 4 only. Number this is equation 2. So if we consider 1 and 2 together, then we can say that A union B complement is equal to A complement intersection B complement. Similarly, we can do A intersection B complement is A complement union B complement. So these two laws are called De Morgan's law. These two laws are called De Morgan's law. So consider properties of complement sets. First one, A union A complement, that is universal set. A intersection A complement, that is 5. If you take double complement, complement of A complement, that is A. All these are verified earlier with the examples. Just a statement only. A union B complement equal to A complement intersection B complement, and A intersection B complement equal to A complement union B complement. See, if you observe, if it is union on the left side, after applying the property, it is intersection. Remember this, both cannot be same. It is union, right side it is intersection. Here also it is intersection and right side it will be union. Remember that, okay? Now last property, phi dash means complement of the null set, that is universal set, and u dash, complement of the universal set is null set. So till now we have studied about set operations, set union, set intersection, difference A minus B, B minus A, and complement also, right? Now all these set operations can be represented using a diagram. So the diagrammatic representation of the sets is and it is named after the English logician John Venn. John Venn. Okay. So diagrammatic representation of the sets is called Venn diagram. Another representation of the set, this one, using diagrams, it is called Venn diagram. So while drawing the Venn diagram, means while representing the set using diagrams, the standard notations, universal set is shown using a rectangle. Other sets are shown using circles. For example, universal set, I'll take it as 1, 2, 3 and 4. If A is the subset of U, I'll take A as 2, 3. Then, according to the statement, universal set is shown using the rectangle. So this is universal set. And A is the subset of that. All other sets are indicated using circle. So A has entry 2 and 3, and other entries I'll write outside because it is there in universal set. Along with the 2, 3, you can write 1, you can write 4 also. So this is the Venn diagram. You can observe from the diagram, it is a smaller set which is inside the universal set, right? From the diagram only we can calculate A dash, means A complement also. Leave A, that is 2 and 3, except 2 and 3. What are the entries left out? Remember, you have to shade those values, that is 1 and 4. So A complement is 1, 4. So, general representation for the universal set, it is rectangle. All other sets are indicated using circles. Okay? Consider Venn diagram showing union of sets now. Showing union of sets. Consider U, this is the rectangle showing the universal set. Consider two sets, A and B. So, how to indicate A union B? You have to merge those two and write the repeated entry only once. So this is a diagram showing A union B. I'll give an example. Take A as 1, 2, 3. Take B as 2, 3, 4. 2, 3, 4. Take universal set 1, 2, 3, 4, 5, 6. Okay. Now, if we consider union, A union B, according to the calculation, you have to combine A and B together. So that is 1, 2, 3 and 4, right? Now, if you check with the diagram, this is a universal set. You have you have two sets, A and B. Now just check whether common entries are there or not. 1 it is not there, 2 it is there, 3 it is there. So first you have to point out common elements. If common elements are not there, then you have to draw two non-intersecting circles. If common entries are there, you have to draw intersecting circles. So now common entries are there, so you have to draw intersecting circles. So this is A, this is B. First fill up the intersection part which is common to both, that is 2 and 3. Fill up the common entries 2 and 3. Now listen to me. From A you have written 2 already, written 3 already. What is remaining? 1. For the set B, see this full circle indicates B. 2 is there, 3 is there, the remaining entry is 4. Now check with the universal set. 1 is there already, 2 written, 3 is there, 4 is there. So what is remaining? 5 and 6. Now, if the question is for A union B, using Venn diagram, you have to shade those values combining these two sets. Combining these two sets. So what this shaded region includes? 1, 2, 3 means A only, except B all other entries in A, that is A minus B, or you can say that A only. Same thing this one, this is B minus A means B only. Now all the three together, as I said earlier, red region A minus B, this is A intersection B, this is B minus A. If we consider the union of all the three, then we will get A union B. There is a formula for that, we will form that later. This is A subset of B. Say universal set is there, B is there and A is there. B is the subset of universal set, A is the subset of B. So A is contained in B, B is contained in U. Complement. See, this is universal set, this is set A. Leave the entries of A and write all other entries which is in U. That is A complement. The brown region indicates A complement. If you take the intersection of A dash and A, gives null set because common entries are not there. From the diagram only it is clear. If you take the union, A union A dash, combine these two together gives you universal set, that is U. U complement out of this null set. Phi complement gives you universal set. Consider Venn diagram showing disjoint sets. So as I said earlier, when two sets A and B are given, before drawing the circles, we have to check whether common entries are there or not. If common entries are there, like this you have to draw two intersecting circles like this and common entry to be filled first. But if the common entries are not there, means like this, A intersection B is the null set, then you have to draw two non-intersecting circles. is 4, minus n of A intersection B, that is 2. So we get the cardinality of A union B. 4 plus 3, 7 minus 2, that is 5. So union consists of 5 elements. See here, n of A is 3, n of B is 4, n of A union B is 5. Depending upon the formula, n of A union B is n of A plus n of B minus n of A intersection B. So this formula is needed to calculate the problems. So there is an exercise using statement problems based on this formula. N of A union B equal to n of A plus n of B minus n of A intersection B. So if you want to calculate using the diagram, n of A union B equal to n of A plus n of B minus n of A intersection B. See, this is A minus B, this is A intersection B, this is B minus A. If we consider this region, that is A. If we consider this orange border region, that is B. If we consider those two together and subtract the intersection part, we will get n of A union B. Okay? The previous formula, this one, n of A union B, is n of A plus n of B minus n of A intersection B. This is when two sets are given. Suppose three sets are given, A, B and C, then to get n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. So this is a formula when three sets are given and diagram will be like this. Consider set A, set B and set C. Listen to me.